Polynomials and radical equations. So first, let's recall the techniques to solve polynomial equations. This is actually quadratic equations. So let's recall for quadratic to solving techniques. For solving quadratic equations. First, if it is in a nice form, meaning it's in the form some quantity squared is equal to some quantity, then you can use the square root property. Next, so in general, if you have a polynomial and it's in a particularly nice form, there may be some sort of way that you can solve it easily because it's in a nice form. Next, if it's not a nice form, well, you can factor it and then use the zero factor property. So in general, especially for higher order polynomials, this will probably be one of the principal techniques that we'll be using until later on, but it will be factor and then use the zero factor property. And so then once I factored it, it's in a nice form so that I can use the zero factor property to solve for the equation, for the roots of this polynomial. Next, if that doesn't work, then use a formula. For quadratics, it's the quadratic formula. For higher order equations, it actually turns out that it's very difficult to use any of the formulas that they have. So I would say, you don't do that. And then lastly, complete the square. So there are techniques that we'll be using further on out that will somehow simplify the equation. Okay, so page 147, use factoring to solve each equation for real values of the variable. So we're trying to find real solutions. So y to the fourth minus 13y squared plus 36 equals 0. This turns out to be quadratic in y squared. So, and it's monic. So we can use the techniques that we know of factoring monic quadratic trinomials. And so I'll just write this as y squared, drop down the minus, times plus is minus. I want two whole numbers whose product is 36 and whose sum is 13. So 9 and 4. I can factor each of these because these are difference of squares. And so this is just y minus 3, y plus 3, y minus 2, y plus 2. So now I factored it into a whole bunch of linear terms. I can use the zero factor property, the fact that integers are an integral domain, to solve this. So I'll set each factor to 0 and solve for y. Add 3, subtract 3, add 2, subtract 2. So what you notice is that there are 4 solutions to this 4th degree polynomial. In general, there will be as many solutions to your polynomial as the degree of your polynomial, so long as you count multiplicity. So if you count correctly, then there's many solutions as the degree of your polynomial. Let me do problem number 20. Several different ways to do this. Here it says the factor, so we'll factor. I could also do this using the fact that this is a radical equation and solve it from there. But what I'll do here is this is a monic quadratic trinomial in p to the 1/2. And so let's factor this as p to the 1/2. P to the 1/2 times minus is minus. I want 2 whole numbers whose product is 20 and whose difference is 1. So 5 and 4. Put the root, which larger absolute value, first. Set each factor to 0 and solve for p. Subtract 5 from both sides of my equation. Add 4 to both sides of my equation. Now let's solve. So let's square both sides of my equation to get rid of the square root. So we're basically just solving a radical equation here. And so p is equal to 25 and p is equal to 16. Recall that whenever we have a radical equation, I must check. So let's check if each of these are solutions to my original equation. And so let's check, is p plus p to the 1/2 minus 20, is this equal to 0? And so is 25 plus the square root of 25 is 5 minus 20 equal to 0. Is 30 minus 20 equal to 0? No, 10 is not equal to 0. So that means that this is an extraneous solution. So I'll get rid of it. Notice, however, if you had changed one of the signs, if you had made this negative, then it would have been a solution. So I do not think that this was an algebraic error. It was probably a correct solution to our technique. It's just that our technique is such that it has a 50-50 chance of giving us an extraneous solution. So this says that this is extraneous. Now I've got to check the other one. So let's check. Let's check. P equals 16. And let's see if that is the solution to our original equation. So P plus P to the 1/2 minus 20, is that equal to 0? Well, the square root of 16 is 4. (20 minus 20) is indeed equal to 0. So that says that my solution is p equaling 16. So that's the solution, in this case, the only solution to our equation. Okay, so let me do problem number 38. 38, sorry. Let's do problem number 38. Find all real solutions of each equation. So in this case, we're trying to solve a radical equation. So to solve a radical equation, well, first thing to do is get rid of the radical. So let me square both sides of my equation. So the square gets rid of the square root. The square gets rid of the -1. -1 squared is just 1. And x plus 1 quantity squared is just x squared plus 2x plus 1. Let's add x squared to both sides of my equation. Let's subtract 5 from both sides of my equation. Let's divide both sides of my equation by 2. And now let's try to factor this. This is a monic quadratic trinomial. Drop down the plus times minus is minus. I want two whole numbers whose product is 2 and whose difference is 1. So 2 and 1. And put the larger root, the root with largest absolute value first. Set each factor to 0 and solve for x using the fact that this is an integral domain. Integers are an integral domain, and the set of polynomials with integer coefficients is therefore an integral domain. Subtract 2 from both sides of my equation. Add 1. Now, since this is a radical equation, I must again check that each solution is actually a solution to the original equation. And so, is the square root of 5 minus x equal to a negative minus 2 plus 1. Well, let's check. And so, is 5 minus 4 rad equal to minus a negative 1? Let me actually pull this down so it'll look a little nicer. Maybe. Okay, so are these equal? Well, is the square root of 1 equal to 1? Yes. So that says that x is equal to negative 2 is a solution. Let's see about the other one. So let's check if x equaling 1 is a solution. And so, do some more space. Is the square root of 5 minus x squared equal to maybe I'll make it look nicer, equal to minus 1 plus 1 is 5 minus 1 equal to negative 2. Is the square root of 4 equal to negative 2? The answer is no. It's not equal to negative 2. Therefore, x equaling 1 is not a solution. And so the only solution here was x equaling negative 2. And that is the solution to my equation. Okay, so let's do problem number 60. The square root of x plus 19 minus the square root of x minus 2 equals the square root of 3. So let's square both sides of my equation. Square both sides of my equation. So the square gets rid of the square root. So the square root of x minus 19 minus the square root minus 2 equals 3. Let's solve this radical equation. So first, let's add to my equation, solving for one of the radicals. Notice I can only solve for one of the radicals. I'll solve for the most complicated of the radicals, the radical x plus 19. That'll make some of the algebra a little bit easier. So x plus 19 radical is equal to, okay, come on. So x plus 19 radical is equal to 3 plus x minus 2 radical. Okay, so let's square both sides of my equation. Now that I've isolated one of my radicals, I can't isolate both of them on one side of my equation. So the square gets, by the special product formula, I get the fact that this is a perfect square trinomial. I get that this is 3 squared, 3 times rad times 2, 6 rad x minus 2, plus the radical squared. Well, the square gets rid of the square root, so x minus 2. And so let's combine like terms. So I get x plus 19 is equal to, combine like terms, x plus 9 minus 2, 7, plus 6 radical x minus 2, subtract x, subtract 7 from both sides of my equation. So 12 is equal to 6 rad x minus 2. Divide both sides of my equation by 6. So rad x minus 2 is equal to 2. Square both sides of my equation. So the square gets rid of the square root. 2 squared is 4. Add 2 to both sides of my equation, so x is equal to 6. I have to check to see if this is a solution to my original equation. So let's check x equaling 6. Let's see if it works. And so I have here x plus 19. Oops. Let's replace x by 6. So 6 plus 19 radical minus radical x minus 2, and the square root of that. Is that equal to the square root of 3? Okay. And so this is the square root of, well, here, let's do that at the end. 6 plus 19 is 25. So I have the square root of 25 minus 6 minus 2 is 4. So that's the square root of 4. And I take the square root of that. Is this equal to the square root of 3? So I have 5. Square root of 25 is 5. Square root of 4 is 2. Is the square root of 5 minus 2 equal to the square root of 3? And the answer is yes. And so my solution is, oops, I don't need that. My solution is just the number x equals 6. And that's your answer.